Okay. So 11.4 dividing radicals. Okay, so last week we did y'all learned about these. We learned about multiplying, simplifying, and multiplying radicals. Now dividing radicals. There's a couple of very important rules that you'll need to know and take with you, especially Algebra 2 and even calculus. You're going to be seeing this a lot. So this chapter is actually really important, even though it's at the end of the book. Okay, you're going to express as fractions. For example, square root of 40 divided by square root of 5. Okay, now there are different ways of doing this. Basically, and I'm going to show you all the different ways of doing this. When dividing radicals, you have to kind of look at it and see which is the best way to go. There's never really one set way, and I'm going to show you by all the examples. Okay, first of all, we're going to express as a fraction. So the square root of 40 over square root of 5. Now, in this situation, are any of these perfect squares? No. This is not a perfect square, and that's not a perfect square. But what can you see? Is there any, Michaela?
They can both be divided by 5.
Okay, they can both be divided by 5. So look, I'm going to change it to like one whole fraction underneath the radical sign. What is 40 divided by 5? 8. So therefore, it's the square root of 8. See, that's how that problem would absolutely 100% be solved. If the numerator can be evenly divided by the denominator, then you go ahead and you do it. Yes, sir?
If it can't evenly go into it, we would use decimals.
Oh, no. We'll go into that in a minute. So the first example is the numerator can evenly be divided by the denominator, so you go ahead and you do that. Now, you always have to simplify. Just because you're done dividing does not mean you're done. Always make sure you simplify. So, we go over here, we do the factor tree, 2 times 4, and then 2 times 2. Just like last week. So then I have 2 times 2 times 2. Emily, what's the root?
2.
That's right, 2. Very good. There's nothing in the check thingy, so we assume it's 2. So how many pairs am I looking for?
2.
Oops, I always do that in red. So I can circle that 2, and then I have this left over. So Emily, what goes on the outside?
2.
What goes on the inside?
2.
And there's your answer. So that pair goes on the outside. What's left over goes on the inside. Any questions on just that? So again, if it can be evenly divided, we do it, and then simplify, and we have our answer. If they were all that easy, we would be done, but we're not. Okay, let's do another. What if I have the square root of 15 divided by the square root of 12? First question, are either one of these a perfect square? No. Can 15 be evenly divided by 12? No. So then what we do is we do just like we did up here. We can go ahead and kind of combine them into one fraction. Michaela?
Do you divide both of them by 3?
Okay, she's going to simplify that. So you're going to simplify the fraction.
Hi, Stephanie.
Right there.
Thank you.
You're welcome. So she's right. We're going to divide by 3 because we're simplifying the fraction. And we get 5 over 4. Now we're not done yet. So up here, we were just left with 1, right? And then we simplified it. Here we're not. So we're going to go ahead and go back to where we were. Square root of 5 over square root of 4. See how I separated it out? Now, if you understand, you could go ahead and skip these two, simplify by 3, and you'll still get this. Do you see what I'm saying? You could go from this step to this step if you wanted. Y'all see that? Okay? So, we're here now. We've simplified it by 3, and we've gotten to here. Is there anything you see? You see something that stands out? What about it? So is that a perfect square? Huh? It is. This is a perfect square. So, Cecilia, what is the square root of 4? So then I have the square root of 5 over the square root, over just 2. In this case, we're done. There's no way to simplify that anymore. No. There's no way to simplify that anymore.
So we don't have to like do like the other.
Nope. There's nothing else you have to do. Because this, the square root of 4, is 2. We have simplified this as much as we can. There, you can't simplify the square root of 5, right? Because it's prime. So then we're done. In fact, if you want, we can say this is a prime number. So we're done. Your notes need to be nice and neat. Okay. Big rule right here. 2 stars. Cannot have a radical in the denominator. It's considered not simplified. You cannot have a radical in the denominator. If you do, it is not simplified. For example, see that 4, the square root of 4? We cannot have that there. Luckily, it was a perfect square, so we were able to change it to a 2. But if it wasn't a perfect square, we would have to get rid of it somehow. You cannot have a radical as a denominator. If you do, it is wrong. In fact, Allie, when she was in calculus, I was helping her on a problem, and she even said, she goes, oh yeah, I forgot. I mean, that is like a golden rule. You cannot, in your answer, have a radical as a denominator, ever. Okay, that is huge. Also, you cannot have a fraction as a radicand in your answer. So for example, see right here, that would not fly. That's why you break it up. If you want to skip this step because you're like, that makes me nervous, and just, reduce here to get to this, and then take that 4 out, you can. But you cannot have a fraction as a radicand in your answer. So if you were to have this, no. So 2 very important rules. You cannot have a radical as a denominator, and you can't have a fraction as your radicand. You've got to separate it, which is kind of like what we did here. 5/4, we separated it. And then we got rid of the denominator. That was a radical. Y'all see that? Does everyone have this? All right. If you have a radicand as a denominator, multiply everything by its equal. I'll show you what that means. Basically, you're going to multiply top and bottom by itself. Bless you. Thank you. Okay, so if you have a radicand as a denominator, a radicand, radical, whatever, multiply the top and the bottom by it, and you'll get rid of it. For example, let's say you do your work and you get this as an answer. No radical in denominator. Okay, so we have that square root of 7, we have that radical down there. You cannot have that there. You can't. Step 1, you ask yourself, can they be divided evenly? Can they be divided evenly? Like right here. Look over here. So 40 over 5. We can't have a 5 in the denominator. We can't have that radical in the denominator. So step 1, can they be divided evenly? And Michaela did this one. She said yes. 40 can be divided by 5. Okay. How about this one? Can they be divided evenly? No, 5 cannot be evenly divided by 7. All right. 2. Can the fraction be simplified? Can the fraction be simplified? Can the 5 and the 7 be simplified anymore? For example, this one. We can't have that 12 down there. It wasn't going to be divided evenly. So then we simplified it and got to here. Right? Can this be simplified anymore? There's nothing that goes into 5 and 7, right? Okay, so let me show you how to get rid of it. We're going to do this right here. Multiply top and bottom by itself. So here I have square root of 5 divided by square root of 7. Cannot have that 7 down there, so we're going to multiply top and bottom by itself. We're going to multiply the top and bottom by itself to get rid of it. Watch what happens. What is, just like what we did on Friday, what is the square root of 5 times square root of 7? What's 5 times 7?
35.
What is 7 times 7?
49.
Is 40 square root of 49 perfect square?
Yes.
What do you get?
7.
Because this is a perfect square now.
Oh, that makes sense.
Yeah.
35 the same.
Now, notice there's no more radical.
I looked back at the notes on what radical means, and it just said the inside
Inside.
there.
The little sign. So that works.
Okay? This sign right
okay.
here.
I wrote it wrong.
Okay. So 35, is it simplified?
No.
What two numbers give me 35?
7.
Are there any pairs?
Oh, yes. 37.
Where? I'm talking about just 35.
35. No.
So then would this be considered simplified? Yes, it is. There's your answer. So if you can't divide them evenly, like on the very first example we did, and we can't simplify it like we did on the second example, then we have to perform this. Got to get rid of the radical that's on the bottom. And you do that by multiplying the top and the bottom by itself. That now gives us a perfect square, because anything times itself will then give us a perfect square, right? So then we can take it out. Square root of 49 is 7. This 35, we've determined, is already simplified as much as it can be, so then it stays. Any questions? All right, let's do another one. Square root of 3 divided by square root of 6. Okay, so we're going to write it as a fraction. This time, let's bypass the big old radical symbol. Let's just see. Can 3 be divided by 6 evenly? No. Can this be simplified?
Yes.
What do we divide top and bottom by?
3.
So then 3 basically divided by 3 is 1. And 6 divided by 3 is
2.
Does everyone see where we got this? Anyone have questions you need to ask? All right. So, can this be simplified anymore?
No.
Can we have a radical on the bottom?
No.
What do we do to get rid of it?
Multiply it by 58.
Top and bottom, right?
Yes.
All right. So we're going to multiply top by the square root of 2 and the bottom by the square root of 2. What is the square root of 1 times square root of 2?
2.
Square root of 2. Square root of 2 times square root of 2 is?
Square root of 4.
Cecilia, do you see anything weird here? 4 again. We have a perfect square. So, Cecilia, what is the square root of 4? So we have the square root of 2 over 2. And this is prime. So then this is our answer. We no longer have no radical in denominator. Any questions? Y'all doing good? All right, let's do another. Y'all ready? Take it up a notch. Square root of 2 divided by the square root of 75. This is where it gets crazy. Now, can 2 be divided evenly by 75? Is there anything that can go into 2 and 75? Can 75 be simplified though? Yes, it can. We're going to do a square root of, a factor tree of 75. What two numbers gives us 75? Gabby? 15 and what? 15 times 5. And then we have 3 and 5. So I have 3 times 5 times 5. Emily, what's my root? So what am I circling? And what's left over?
The 3.
Good job. You're going to be able to do that in your sleep because I keep bugging you. All right, so check this out. That was only on 75. So we didn't do anything with the 2, so the 2's going to stay. The 5 goes on the outside, 3 on the inside. All right, so write that down, sit back, and see if you understand that. Anyone not understand this? The 2, we carried over. We simplified the 75 more, and we get this. But Emily, am I allowed to have a radical in the bottom? What do I need to do? Multiply what? By the radical, right? Okay, but notice we have a 5 here. We have a 5 here. Okay? So we're going to multiply the top and the bottom, but it's only going to be the radical that we do that with. We only multiply the top and the bottom by the actual radical. What is the square root of 2 times square root of 3, Cecilia? The square root of 6, right? Now, we have a 5, and then what's the square root of 3 times square root of 3? So then we have 5 times square root of 9. Do y'all see where we got that? Are y'all with me? This is a perfect square. So what's the square root of 9? Okay, it's 3, right? Okay, now remember the 5 is being multiplied by this, so we have the square root of 6 over 5 times 3, because the square root of 9 is 3. And then 5 times 3 is what? Now, 6 is prime. Because if we were to do the factor tree, we'd only have 2 times 3. And there's no pairs. So, this is your answer. So, write that down. I need you to kind of take a step back and look at that. We first simplified the 75 factor tree, and we got the 5 times square root of 3. Cannot have square root in the denominator, so we multiply top and bottom, according to Emily, by square root of 3. 3 times 2 is 6. 3 times 3 is 9. That 5 is staying right where it's at. 9's a perfect square. That gives us 3. But that 5 is being multiplied by that, so it's 5 times 3 is 15. Any questions? All right. Y'all seem to understand it. Page 449. Let's do examples. Number 1. 449. Emily, what can we do with this? Do you notice anything?
4 and 5 are perfect squares.
Ah, both are perfect squares. So what's the square root of 4? And the square root of 25? Guess what? You're done. That's simplified too. Good. See, you got to sit back and look at it because it might be that simple. If it's already in perfect square, man, you're good. Good job. 3. Square root of 5 divided by square root of 4. Michaela, first thing we do is rewrite this as a fraction, right? So we have square root of 5 divided by square root of 4. All right, what do you notice? Are you sure? Just take a look at it first. Nothing jumps out at you? There's no red flag?
4.
What about the 4?
2 times 2.
It's a perfect square. So the 4 is a perfect square. So already,
2.
that's it, because the 5 is prime. We can't factor that anymore. So we're done. And you can't do like 5 divided by 4 or anything. So see, sometimes these will work out really nice for you. 5. Sometimes they won't. For example, Cecilia. Square root of 8 divided by square root of 4. It is. However, can these be divided evenly? What is 8 divided by 4? So we can have the square root of 2. So you want to check that out. If they can be divided evenly, then you need to do that. Can this be simplified anymore? There's your answer. Now, let's say we go and do like what Cecilia had said. She said 4 is a perfect square, and it would be 2, right? So we take it out. Is 8 simplified?
No.
So then we would do a factor tree, 2 times 4, and 2 times 2, right? We list our prime factors. We have a root of 2, so we're going to circle, and that's what's left over. Now, I have this square root of 8 has now become 2 times square root of 2, right? Over 2. Do you see that? Does everyone see that? So she took the perfect square, took it out, factored the 8, and we get this, over 2. Cecilia, can we do 2 divided by 2? What does that become? So really, those cross out, and we're left with square root of 2.
Those bits are both on the outside.
Huh?
Those bits are both.
That's right. Because this is on the outside, and this is just a regular 2. Emily, are you looking? That's a regular 2, and that's a regular 2, so 2 divided by 2 is 1. So, yes, Cecilia had originally said, well, that's perfect square. Let's go this route.
So it's not wrong. Is it right?
Nope, it's not wrong because both you get the same answer. Y'all probably should have that written down. Any questions? Does that make sense, Cecilia? Okay. Let's do another. Number 7. Square root of 10 divided by 3 times square root of 5. Michael.
Oh, can we divide
What?
10 and 5?
Yeah, look right here. Can 10 be divided by 5? Yes. What do you get?
5.
square root of 2 over 3. Because that 3 can stay there. You divided that 10 by the square root of 10 by the square root of 5, you get 2. That 2 is now prime. There's no radical here. We can't do anything else, so there's your answer. Any questions? Everyone have it down? If you're writing, I think you're still copying, so I don't know. All right, number 9. Three over the square root of 13. Gabby. That's right. We're going to multiply the top and the bottom by the square root of 13. Now, notice, this is a regular number. That is a square root number. Do y'all see that? Emily, do you see that? So therefore, 3 times square root of 13 is just that. 3 times square root of 13. You don't do anything else to it. And what's going to be down here? Because 13 times 13 is 169. What's the square root of 169? 13. We no longer have a radical in the bottom. These two cannot be combined. Can 3 be divided, or can this be simplified, the 3 and the 13? No, it cannot. There's your answer. Cecilia?
When do you know to do that with the 13 and 13 times the 3 and the 13?
Well, this is not in a radical sign. It's just a regular number.
Okay.
Does that help? All right, 11. I got 3 more problems. I'm setting you free. With 1 divided by the square root of 6.
You would multiply the top and the bottom by 6, or the square root of 6,
Very good.
and you would get 1 times the square root of 6,
Or
Just
just
the
square
square
root
root
of
of
6.
over the square root of 36. And then it would be the square root of 6 over 6.
And that's it.
Yeah.
Because we can't divide this. That's totally separate entity. Square root of 6 divided by plain old 6. Can't do it. You're done. You're done. Yeah. Okay.
Hey,
I'll stay
yeah.
off of social media. Yes.
Because it's the square root of 6 or the square root of 36. Can you just simplify it?
Well, except for the fact that then it would be 1
Yeah.
over 6, and you cannot have a radical in the bottom. So this is a perfect square. You always want to take it out.
Oh, okay.
Good question. All right. 13. Aiden, square root of 14 divided by square root of 21.
Think of those be divided by 7.
Oh, I like that. They can both be simplified by 7. So here we get the square root of 2 over the square root of 3. Now what do I do?
You multiply the top and the bottom by the radicals of 3.
Yeah. And what do you get?
power 6. Wait, sorry.
You can say radical 6, I don't care.
Radical 6. Radical 9.
And then what do you get?
Add radical 6 over 3.
And there's nothing else we can do. It's just like this one. So we're done. That 6 cannot be simplified anymore because there's no pairs. It'd just be 2 times 3.
76.
Yeah. Any questions? Emily, you ready for the last one? You got this. I'll be with you every step of the way. Okay. Now, this is kind of like what Aiden was saying here. 3 times square root of 5 divided by square root of 15. Now, Emily, can these two be divided or simplified? Like, 15 can be divided by 5, right? Okay, so 15 divided by 5 is what? Okay, so what I have is this 3 is left over, this is gone, and I have radical 3, square root of 3. Before I move on, does everyone see that?
So we divided 5 and 15 by 3. I mean,
Well, look, 15, look up here. 15 can be divided by 5 evenly.
so then it goes away.
It goes away. Okay, now, what can I do? Multiply, because we can't have this there. There's nothing else we can do, so we're going to multiply the top and the bottom by the square root of 3. Good job. And what do I get up here? Can we do plain?
So
3 times the square root of 3. Good job. Now, here, they're both radicals, so square root of 3 times square root of 3 gives us. Now, what's square root of 9? So this doesn't change, but I have 3 down here. Emily, is there anything else I can do? Cancel the outside 3s. That's right, because 3 divided by 3, these are plain old 3s, is 1, which really, like she said, you can just cancel them. So then your answer is just the square root of 3. Very good. Any questions? All right, so it's going to be that attention to detail. Slow and steady will win the race. You will do numbers 2 through 16 even. $44 and $46. And then so y'all can get started. Two through 16 even. I'm gonna be nice. I think I might just leave it at that. Yep, I'm gonna be real nice. This is due Tuesday. Tuesday you have a quiz. All right, get started.